This is the help file for the graphical user interface for the StoneEdge telescope. Before we can use the user interface, we have to connect up a tunnel between our computer and the telescope. The telescope is protected by a firewall that keeps unwanted users from accessing the telescope. We have a simple tunnel application that allows us to connect to the telescope, and then we can pass commands back and forth in a secure way. This application can be gotten a hold of on the web at the following web page. The web page address is located here. The application, which is StoneEdge can be saved to your disk, any folder. I made a special folder on the desktop. And the application is downloaded and saved. We'll open up the folder to take a look at open the application. The application is StoneEdge It's a Java program. Double-clicking on the application will open the tunnel. You'll see the tunnel has a closed window. You connect the tunnel by pressing the Connect off the main menu. You need a key to open the tunnel. The key is provided by the observatory administrator. You locate the key, and then the tunnel is opened if the key is correct. This shows the open tunnel, and now the application is ready to be able to connect commands back and forth between the telescope and your computer. The tunnel has to stay open. You cannot close the tunnel while you're using the application. Otherwise, no commands will be sent back and forth. The user interface is a web-based user interface and can be opened now at this web page, which has a unique address called localhost:8080 StoneEdge 2. You have to use this address, and this is how to get through the firewall. There's a number of menus. The introduction page, the telescope control page is which we'll use the most. You'll see a login page, which we'll come back to in a little bit. There's a phone number and an email. There's a status page. The status page has a number of important information like the status of the slit, the dome, the weather, the filters, whether or not the sun is up, and then there's a clear sky chart that tells you whether or not it's cloudy or dark in Sonoma. There's the targeting page. As you see with the targeting page, there's not much you can do because we have not logged in. So the dome is closed, software is unlocked, and it tells you that if you want to use this page, you have to go in and log in. So before we go any further, we'll log in. The login page, to log in, you enter a phone number that you can be reached at in case someone needs to get a hold of you. You give an email address, which will be used as your data, and it would also be used for people to write you in case there is a problem. You lock the telescope. Now you have control of the telescope, as Yoda tells you. You can unlock the telescope, or anybody can unlock the telescope, but this is kind of on a gentleman's agreement. The agreement is to notify somebody either by email or phone if you'd like to unlock the telescope. Using the utility menu, we can take a look at the dome camera. The dome camera is very handy to see whether or not the telescope is operating the way we think. It takes a little bit for the dome camera to show up. because of the high amount of traffic, data traffic to go through. Once the dome camera shows up, you'll see it very dark if there's no lights on, and if it's dark outside. You could turn lights on if the dome is closed. Turning the lights on will show the inside of the dome with the camera. It's best not to turn the lights on when the dome is closed. You can move the camera up and down using the up and down arrows and also the left and right arrows to center the camera where you'd like. And remember to turn the lights off before opening the dome. I like to leave the dome tab open and open up another tab so they can go back and forth between seeing the dome camera and seeing the other parts of the application. So the next thing to do is we're going to use the targeting. We'd like to open up the dome. So that's under the telescope control targeting page. The dome is closed. The software is locked by me at this point. The slit's closed, the tracking's off. Pressing the open up will open the dome. It will take a while for the dome to open. But you can use the dome camera to see the dome opening, as you can see here, and watch the status as the dome opens. Once the dome is open, you like to go back to the telescope control page to see the status. The dome is open, the tracking's on, and the slit is open, as shown in the output here. The next thing to do is pick a target. This is underneath the catalog page. Pressing the catalog will open up the catalog page. And there are a number of targets. This is the default catalog, and there are only a few targets available at this point because of the limited number of entries in the catalog. You can get some information on the targets by clicking one of the info links. And this is M81. It goes to the Wikipedia page. This is programmed by the user and can be changed if one would like. The green signifies that it has a light air mass, shown by here. Red is a heavy air mass, and yellow is a medium air mass. We'll pick M81, and we'll click on the target. Clicking on the target will bring us back to the targeting page. And you will see that it picked M81 as the target. It's in red. It'll show you on the screen where it needs to go with the telescope with the red azimuth and the red altitude of where the target is. The green is where the telescope is currently pointed, which is straight up. So you can see how far the telescope has to move. The telescope set the M81 target, and you might want to alter the coordinates. You might want to think that put a little tweak into the coordinates. You could do that by entering the RA and DEC manually. The RA and DEC boxes come up, and you can edit the numbers. So here I'll just make a tiny little change on the RA. I'll say OK. And now the new RA and DEC have been entered in. Besides using the catalog, one can use the Horizons catalog from JPL to get a hold of objects such as planets and asteroids that are transient or move every night and don't have a fixed RA. You have to know what the Horizons number is, and for example, Mars is 499. You enter the 499 number in, which is the Horizons catalog number. And we'll go out and search for the RA and DEC, and you can see that Mars is not visible. It will tell you that horizon number 499 is not visible, so you can't slew to that and the same target stays up. So Saturn is visible, so we'll type in the Saturn horizons number, which is 699. Hit the horizons. And you can see that Saturn is visible, and now we'll put Saturn in as far as the target. So this is another way to enter in objects that one would like. Besides using the default catalog and the horizons and entering the RA and DEC manually, the user can actually modify the default catalog. The default catalog has a limited set of objects that can be changed. The best way to change it is use the default catalog as a template. So the link to the default catalog is provided here. You can save that link onto your computer and then edit it and make your own catalog. So I'm saving the link to some folder on my computer. I'll go and rename the catalog. Instead of default catalog, I'll rename it as Dave's catalog. It's an XML document. It uses XML format, and you have to be careful about the format and how you edit the file. You can edit the file with any text editor. I like to use Notepad++ to edit XML documents. It's a nice editor you can get free off the web. And you can now find the catalog that you saved, Dave's catalog. If I open it up with Notepad+2, you'll see the XML file, and this is the default targets that have been placed in there, which are mostly messier objects. So what I'll do is I'll go ahead and select a large number of them and just remove them. Okay, so I'm left with 3 targets. I'll go off and save that. And now I can go and add or modify the targets that are in there. There's XML tags that you have to pay attention to. You have to start with catalog, and you have to end with catalog. And in between are the children tags that are called the targets. The targets have an alias, which is called its name, for example, Saturn. The epoch, which most of the time is 2000. For planet, you can use a horizons number, and then you will not need to put in RA or DEC if you just use a horizons number. Or if you want to have an object that has an RA and DEC, you then have to put in the DEC, the epoch. You can put a link in which contains information so other users can find out about that object, a magnitude, a name instead of the alias, the right ascension, the magnitude, the name, the right ascension, and the declination if you do not use a horizons number. And then a type, which really doesn't mean anything just as long as it's a descriptive word of what it is that you're looking at. So now I have my user-defined catalog, and I'm going to now upload that catalog to the web interface. I do that under using the change button. Hit change. I choose the file I'm going to upload, which is the one I just edited. Dave's catalog. I chose the file name, and then I upload it. Now you can see that the catalog file is Dave's catalog. Okay, so now we can go and take a look at the catalog. Remember, there were only a very few number of items. It takes some time for a new catalog because it has to load the new horizons numbers in. And you can see now, out of the 3 objects, only 2 were visible at this time that I'm doing the observing. And so this is my new catalog that I could use for my observing session. I'll go back. And if I don't like that catalog and I want to go back, I can always revert to the default. So pressing here just reverts to the default and removes Dave's catalog and puts the default catalog back in. And go back and look at the new catalog, at the default catalog, just to make sure that it got entered in. And here are the objects that are visible now with the default catalog at this observing time. So now I've gone back and put the default catalog back in. The next step is a slew to the target. So to do that, let's go back to the M81 target that we had before. And you can see the M81 coordinates that we added in. And to go there, we hit slew. Now the telescope will start moving to the new target. And you can actually see that on the dome camera, where you start seeing the object, the telescope, starting to move. It takes quite a bit for the telescope to slew if it has it to go a long way, and so it's always nice to look at the dome camera to see how the progress. Okay, once the telescope stopped moving, you can go back to the targeting page, and you can see that the status is that the telescope's at the target and that it's done moving. The next step is to acquire an image. Just press that Acquire Image link. And the Acquire Image page comes up. There's a focus panel, the username, the session, the date, the data path where the data files will be stored. There's the filter page. Again, the focus panel. And then the controls for taking the image. The shutter time, the binning, how the pixels are getting together, the image number, the date if it wants to put it on there, darks, and again the filters just selected. So we can change the shutter time. We'll add in 100 for this object, and we'll go take the image. Okay, once the image is being acquired, there's a page that comes up and says, in progress, do not leave the page. Since it's a web page, it cannot remember where you left off if you went navigated to another page outside the server. So it's important not to close the page and leave this page up while the image is being taken. Once the image is completed, it'll go back to the Acquire Image page, and the image will show up. A black and white image for the given filter, which was clear in this case. And you can see some information. It told you what the star size is in terms of pixels. This is helpful for adjusting the focus. And the star it picked is usually something far outside the field. And it tells you this is the size star you have. So what you'd like to do is adjust the focus to make this a minimum value. In the future, there'll be an autofocus routine. There's also an exposure level, which tells you whether or not you've overexposed. it shows you the places you've overexposed in red. So if you're not interested in those parts, you don't have to worry about it. And it shows you that you're exposed at 50% in green. So you'd like to have most of your image or things of interest in white or green, which tells you basically you have a good exposure time. Other than that, if you don't like that, then you change the number of seconds that you would like on your exposure time. It gives you an image name, which is a target, the filter, the time it took for the exposure, the binning, and also an index. You can then save the image. Once the image is saved, it will be saved into the data path for retrieval later. The next thing you might not be happy about the image is that its location. It might be, in this case, it might be a little bit too high in the image, and you would like to move down the target a little bit into the image. So you can do that by nudging the target under the targeting panel. Targeting panel comes up, and you see that there is a nudge subpanel in which you can nudge the telescope in RA or DEC. So as an example, we'll nudge in declination. And we'll add like 0.1 degrees, and we'll just go ahead and nudge it. So we're just going to move the telescope a little bit when we hit nudge. And it's with respect to where you already started from. So the telescope has been told to nudge. It moves a tiny bit. Still takes a little bit for the telescope to move. And now the telescope has moved its little bit. It's told you that it's done the offset. And let's go take another image to see where we're at. So we take an image. Okay, so the next image, the nuke image comes up, and you can see that I guessed the wrong direction. And now the target has moved way off center towards the top. I should have gone into the other direction. So I'm going to go back and change the offset. Under the targeting page. I go back under the declination, and since the offset is always with respect to where I'm at, I'm going to have to put in minus 0.2 to go in the other direction. So I go ahead and I nudge it, and then the telescope goes off and nudges in the other direction. Okay, once the telescope has nudged and it has let the user know that it's moved to the new offset, I go and acquire a new image to see where the object is on my image. So I'll take the image, and now you can see that the object has moved down in the image into a better location. So then one goes off and centers the object to where you would like to have it into the image. Okay, once the object is located where you would like it, next thing to do is probably take images of using different filters to get for a color image later on. So let's go over and take an R band. Keep the same shutter time, and then we'll take an image. And again, wait till the image is completed. So now the image with the new filter, the R filter, has shown up. It's a lot dimmer than it was with the clear. That's because of the filter has less transparency, and you see less of the saturated objects through the image. You can see now the name has been indexed. The name of the filter has been automatically added. The R band has been automatically added to the name. The shutter time has already been added, and the object name has been added. You can save the object. You don't have to save every image, just the ones you are happy with. Once you save it, the image disappears, and you're ready for the next image. The next thing to do, finally, before you're done with a target, it is always good practice to take a dark, which is the image with the shutter closed. This gives the offset of the CCD camera that you'll use later for image processing. So for every object, I always take one dark with the same shutter time that I used for the other exposures. And now you see the dark is perfectly black, because the shutter was closed, and you're going to use this image for image processing to subtract off the pedestal. There's a dark that gets put in the name of the image name automatically, and again the index, and you'll go off and you'll save this. Now, all the images that have been saved into the data path. You can go off and see the images you've taken. We've taken 3 images in this session, and they're saved as FITS files, which are astronomical formats. Will be used later for image processing. So we took a clear, an R band, and a dark. Okay, these files can be saved to your desktop by just right-clicking onto the files, saving the link, and then they can be saved to your computer, wherever you'd like to choose to save it. I'll put it in the directory that I've made earlier. I'll save it with the name, with the FITS file name. Saved, which might take a bit because of the internet connection. Once the file has been saved to your folder, you can take a look at it. And there's the file sitting in the folder on the computer. Going back to the Acquire Image page, it's time to wrap up the observing session. So we go back to Targeting. And now, to close down the telescope, press Close Down. This will close the slit. This will home the telescope, and will log the user off. The progress of the close down can be monitored by looking at the dome camera and watching the telescope go back to its home position. Once the telescope has reached its home position, the dome is closed, the slit is closed, which you can see here in the status. The tracking is off. You can go back to the targeting page, and now you can see that the dome is closed, the software is unlocked, the user has been logged off, slit's closed, tracking off, and again, the user's been logged off. There's a much easier way to save files than was done previously onto your desktop. Saving the link one by one is a painful process. The tunnel has a feature that allows the user to save files, many files at a time. You can read about that underneath the help, or you can just watch the video. You go into File, Transfer Images. A window pops up and shows the main StoneEdge directory. You have to populate it by clicking on it. So clicking on it populates it. You can then see all the users' directories. You can then find the directory of interest that you would like to download files. Demagins, click on it to populate it. Open the switch. Find the date of observing that's of interest. Which will be March 9th. Click to populate. And open. And you see the 3 images that were taken during the day. You can then download the entire folder by clicking download, selecting the location, which we'll put in the same folder we had before. And just selecting the folder, it will download the entire folder with the name that was on the server into your local computer. You can see the status. The first file is being downloaded at this point, and you wait for all the files to be downloaded before the program will relinquish control. Once the files have all been downloaded, there'll be a completed exclamation point at this point here, and all 3 files have been downloaded to the computer without having to do it one at a time. To see that, you can open up the folder where the files have been stored, and you can see that it named it with the date of the observing session that was taken. And then the 3 files that were taken during the observing session are shown here. Then the tunnel can be shut down and disconnected. The tunnel is successfully disconnected. You'll see the closed Stargate, and that's the end of the help file.